All right, we're on to our last type of problems. Again, these are going to be more common. Okay, so these up here that we just dropped the logs, it's not going to happen very often. But this time, if you have a log base 4 or something on one side, what you're going to do, just like type 2, you're just going to switch forms. Okay, so remember again, we'll just try to one more time. B to the x power is equal to a. That can go to logarithmic form as the log base b of a is equal to x. So we're actually going to be working this way this time. So we're going to identify our base and raise that to the other side power. So base to the other side power, so our third power, and that's equal to this 5x minus 1. Now it's a lot easier to solve. Okay, in fact, 4 to the third is just a number. Your calculator, if you plug it in, 4 caret 3, tells you it's 64. Now it's even easier to solve. You're just going to add the 1. So 65 is equal to 5x. Then you can divide by 5, and x is equal to 13. Again, anything that has a log in it, just do a quick check for extraneous solutions. 5 times 13 is a big number. When I subtract 1, it's still a positive big number. So go ahead and just circle that. You're done. Super job. Nice work. Okay, now we saved the best for last. This one, sometimes before you could switch forms, notice there's not logs on both sides of the equation, first of all. So there's just a number over here, but there are 2 logs over here. You're going to need to condense, just like we did earlier on those. You're going to need to condense this. Now, the main thing you're going to need to take note of right here is that you got this addition sign. So really what this means is you could write this as 1 log of these multiplied together. This x plus 9 multiplied to x. So that is equal to 2. So let's go ahead and actually distribute this x to both terms right here. So we'll have the log base 6 of, and there's 2 terms, so we'll write them in parentheses, x squared plus 9x is equal to 2. Good. Now we've just got log on one side of the equation all by itself. So we are going to write the equation in exponential form. So identify your base first. 6 to the other side power is equal to x squared plus 9x. Well, what is 6 to the second? 36. Very good. All right, you knew your teacher was going to throw this at you. I told you, warned you. Quadratic equations are not going away. You've got a lovely quadratic equation. All of these have been linear up till now, just x to the first. Now we've got an x squared. Okay, do not fear. You could solve this by our factoring method. So we're just going to get it equal to 0. Okay, so let's subtract our 36 from both sides. So 0 here is equal to x squared plus 9x minus 36. And your favorite thing to do, we're going to let you factor. All right, so remember our first times our first multiplies to this x squared. That one's easy. But it's your last numbers that multiply to negative 36. But combined, when you combine your inside and outsides, they've got to add to this 9x. So we know they're different signs as well. You've got a negative and a positive. I'm going to put a 3 here and a 12 here because 12x minus 3x is 9x, but negative 3 times 12 is 36. Okay, now the reason that we factored this is because now it is a linear equation. Basically, you just set both of these equal to 0, and you could say, well, if x is 3, 3 minus 3 is 0. 0 times anything is 0. Okay, or if x is negative 12, negative 12 plus 12 is 0, 0 times anything is 0. So there's 2 answers. Do not circle your answers here, however, though remember, we're going to double check. Plug this back in to the original equation, actually. We're going to go clear back up to here, and we're going to say, okay, 3 plus 9, positive number, checks. 3, positive number, so that one works. That one's okay. We can circle that one. Negative 12 plus 9, however, is negative. That is also negative. So you're going to cross that out. That's what we consider our extraneous solution. Only circle that x is equal to 3. All right, that finishes the homework for this whole unit. Enjoy solving some of these on your own.